we've only been working with expressions so far in terms of our factoring. Now we're going to look at solving equations by factoring. So everything that you've learned about factoring is still going to come into play. It's just that we'll be able to go further and actually get solutions. We'll be able to solve for x because we'll have equations on our hands now. So let's check it out. The key idea is the zero product property, or the zero factor property. I usually call it the ZPP for short. Zero product or zero factor property. And simply stated, if A times B is 0, if that's true, we're told that two expressions multiplied together is equal to 0. Either A is 0 or B is 0. Now, this either may seem very clear to you, or it might seem very confusing. So let's just talk about it for a moment. Let's say A was 0. If A were 0, do you agree that 0 times B makes 0? So that's why we can say A must be 0, because 0 times B is 0. And if A is not equal to 0, then B could potentially be 0, because isn't A times 0 also equal to 0? So those are the only two ways to get a result of 0. Either the first thing equals 0 or the second thing equals 0. And we can extend this. Let's say we have A times B times C equals 0. If that were true, then we'd have the same conclusion, but also perhaps C could equal 0. So this idea is huge when you go from just factoring expressions to solving equations by the process of factoring. In the end, once you've factored, that's really what we're saying here. Once you've factored, and if those factors are set equal to 0, you can then break each factor up and equate it or set it equal to 0. That's the key idea. So, in order to be able to apply the zero product property, you need to make sure that you get everything set equal to 0. That's the first checkpoint. You got to combine like terms, get everything set equal to 0. I recommend having your quadratic term be positive, by the way. Like we could have subtracted 12x squared from both sides, but then we have a negative 10x squared, and that gets a little bit more confusing. So I would always add or subtract and combine like terms, move things around so that your quadratic term is positive. Now what's interesting is this green box we can factor, because it's just an expression, but it's set equal to 0. So we can factor by grouping. And then right here, we have A and we have B. We can apply the good old zero product property. Either the first expression is set equal to 0, or the second expression is set equal to 0. And then these are just linear equations that we can solve for, and we can get our two solutions. So everything that was boxed in green is what you're used to. That's just expressions, if you will. But you just need to make sure that you set your equation equal to 0 first, and then afterwards you apply the zero product property. So that's the new layer of complexity. It's kind of like a sandwich. You have the meat of the sandwich done. And if you're vegetarian, the non-meat. It's fine. You have the meat of the sandwich. Factoring. You know how to do that. But now you just need to make sure that you're set equal to 0, and then you can factor, but notice how this is an equation every step of the way. So it's got to be set equal to 0. Then you factor like you're used to, and then you apply the zero product property, and then you solve for x. So the bread is the equation work, if you will, but the green, the factoring, is an integral piece or part that you already know how to do. You just got to make sure that everything's set equal to 0 first, and then apply the zero product property on each factor once you've factored. That is the process known as solve. So now we can still do things like we're used to doing. We just now are going to add the equation aspect to it. So what's nice is this is already set equal to 0. That's the first thing that we need. We need to add or subtract combined like terms so that it's set equal to 0. So that's the first part of the bread, if you will. And then we know how to factor this. We're going to apply the AC method. We need to multiply to negative 12. And we need to add to what number's in front of x but 1. So those factors, what will they be? Let's see, we'll write down the a and the c terms. We're splitting up that middle term. Looks like we're going to go for positive 4x and negative 3x, because 4x minus 3x, that makes 1x, but 4 times negative 3 is going to multiply to our negative 12. And then we'll factor by grouping. Again, this is what we're used to. Pull out a 4x. This term is negative, so we'll pull out a negative 3. And I'm going to write the GCF second, just to show you that it's okay. And then we can set each factor equal to 0. Now I strongly recommend doing out this work. Many of you could just eyeball this and say, oh, I know x is going to be negative 1, but really show it so that you're extra careful. Like here, some students will think, oh, I'm just going to add 3 to both sides, x is 3, but really, 4x is 3. And we have to divide by 4. So we get our solutions of x equals 3/4 and x equals negative 1. And what's nice is, since this is an equation, we could plug in either one of these solutions into the original equation. We can see that we're true. We are correct. So number 2 here, we have to do a little bit of work. We have to do a little bit of rearranging. I recommend bringing everything to the left-hand side so that the x squared stays positive. So be careful, you can't just pick it up like the claw and move it over. You have to subtract 8x from both sides, which will make our equation look like so. And again, our first mini goal is to get this set equal to 0. The inverse, or opposite of negative 15, is positive 15. So we'll do that to both sides as well. X squared minus 8x plus 15. Now, since we've done so much factoring, I'm just going to factor this right quick. You know how to factor by grouping. We're going to do x minus 3 and x minus 5 here. And then right here, we have a and we have b equal to 0. So we'll set a equal to 0. That's our first factor by the zero product property, the zero factor property. And b, we can also set that equal to 0. So once you have factored and set it equal to 0, you may set each factor equal to 0, because that's how multiplication works to result in a 0. So now we have x equals 3. And we have x equals 5. And that's the process of solving by factoring. Again, this region right here, if you think of this as an expression, you know how to factor this. You know how to factor by grouping, or however it is that you factor. Just beforehand, you got to make sure everything's set equal to 0, and afterwards you apply the zero product property and solve for x. That's the name of the game. What's kind of funny about question 3 is it's already factored. So this is just, oh no, I was hoping I was hoping that this problem read x minus 7 times x plus 3 equals 0. So then we could just apply the zero product property and we're done. But I regret to inform you we can't do that now. So question 3 is actually going to require a lot of effort because it's not set equal to 0. So we're going to have to multiply this mess out of x squared minus 4x minus 21. That equals negative 9. Now we're still in this beginning phase of getting everything set equal to 0. So if we add 9 to both sides, x squared minus 4x minus 12 equals 0. Okay, first phase is done. Now we can factor by grouping. We're asking ourselves what adds negative 4, multiplies to negative 12. That's going to be negative 6 and positive 2. Again, I'm going over the factoring quickly because we've factored so many times beforehand. And now, since we have two factors set equal to 0, we may apply the zero product property and set the first factor equal to 0 and the second factor equal to 0. So we have x is 6 and x is negative 2. So be careful. I almost jumped to conclusions. I really just wanted to use the zero product property here, but we were set equal to negative 9, not 0, so we had to multiply everything out on the left-hand side, add 9 so that everything was set equal to 0. That's the first checkpoint. Then we factor, then we apply the zero product property and solve for x. Now this last problem, there's going to be a lot of effort here to get this set equal to 0. I'm going to bring everything to the right-hand side so that my x squared term is positive. Okay, so I'm going to subtract 3x squared from both sides. I'm going to subtract 4x from both sides. Interesting. And I'm going to add 5 to both sides. I basically, whatever I do to one side, I'm doing to the other side to get the entire left-hand side to make 0. And now I'll combine my terms. I have 4x squareds remaining. Oh, it's kind of interesting. The x terms cancel, and we have minus 9. Okay. Now, this is an interesting problem, and there's many ways to do it. I'm going to do it the way that it has always worked for us, which is factoring by grouping. We're looking for, so let me just kind of go over this a little bit more in detail. We have 4x squared plus 0x minus 9. So as a reminder, we're looking for numbers that add to 0 and that multiply to good old negative 36. Okay, so if they add to 0, they have to be additive inverses or opposites in an additive sense. So 6 and negative 6. 6 times negative 6 times 6, that's going to make negative 36. But negative 6 plus 6, that's going to make 0 because there's no x term here. So I just kind of wrote that in just so that we could visualize a little bit better. So we're going to break up 0x into plus 6x and minus 6x. Now we're going to factor by grouping. Okay, greatest common factor at 2. Greatest common factor at negative 3 because that term is negative. Watch your signs there, Mark. And so we have 2x plus 3. And so this factors into 2x plus 3 and 2x minus 3. Set each factor equal to 0. Do the workout. I'm running out of space. You'll get x equals negative 3 halves and x equals positive 3 halves. So definitely an interesting problem, especially because the b term disappeared. And there we go. We have our two solutions. Keep in mind this is a quadratic, so we will have at most two solutions. We could have one solution, and we could actually have no solutions, and we'll look into that later in the course. But so we got our two answers. Very good.